What kind of careers are available in this space on a broad term? Now we keep hearing about software as a service, platform as a service, infrastructure as a service. Can you kind of break it down into understandable terms?
Or you want to manage everything, you want most control. So you'll get that infrastructure as a service.
Another term which comes out with cloud is public, private, and hybrid. What are these formats of clouds?
It is like made for each other sort of thing, AI and cloud.
Is AI going to increase or decrease the cost of cloud computing? For an enterprise or for an organization, how does AI impact their kind of cloud strategy? Saying, okay, you have to go on cloud. How does AI impact, or is it going to have any impact?
The data residency is the very important problem. Data at rest and
People not able to utilize 100% of the cloud cost which they are paying. Can AI help them in kind of optimizing that waste? Cloud computing has come a long way. It has become an integral part of enterprise storage and computing space. Just to give you some data points, almost 60% of the enterprise data now is stored in the cloud. Combined revenue of Amazon, Microsoft, and Google is more than $300 billion. So it has become really an integral part to how enterprises store and compute their applications. Now, the entry of AI is going to affect the cloud computing, or it is not. What is the prognosis? Is it going to have a positive impact? Is it going to have a negative impact? In today's episode, we are going to discuss all of that and more. Welcome to a brand new episode of Future Forward, a podcast series by Techcanvass on artificial intelligence, business analysis, and product management. Okay, let me introduce the guest for today. Paritosh Darekar is an Associate Director, AI Labs, building enterprise-grade GenAI and AI products powered by cloud-native architectures. Working at the intersection of cloud, data, and AI in the age of intelligent systems, designing scalable platforms that turn ideas into real-world impact. He is passionate about shaping how enterprises adopt GenAI responsibly, combining innovation, architecture, and business value at scale. Hi Paritosh, welcome to the show.
Thank you so much. Yeah.
So let's start by understanding how did you get into this field and a little bit more about your career so far.
Yeah. So my career spans about, it's been over a decade. Okay. It's been almost 12 years since I've been into this domain, particularly into technology, right? So I started out as a traditional software engineer. Okay. And then moved into data systems, managing data systems, building data systems. So I'll tell you, so while I was working as a traditional software engineer in particular, it was about building beautiful features, shipping code, and then making it all accessible to all the internal users, right, particularly. And back then when I started, the clients were mostly banking and insurance companies to whom I was working for. And it was early on during that stage itself when we realized that now banking and insurance sectors particularly, they build applications, which is a few applications are built for the organization, for the internal systems, but also for the customers, right? B2C, it is a B2C market at the end of the day. So when these applications or these applications particularly are built, the consumers is the real masses and the people, right, out there. So the scaling, elasticity of this application became a core component of the applications which were built or the softwares which were built right at the very beginning. And that is how I moved into understanding these scalability, elasticity, performance engineering, right, at the very beginning. And so it was about 2016-17, around that time. Okay, 2 years into the development, right, and with data systems. And then 2018, it was around 2018 when I moved into AI, but heavily into AI or like full-time into AI. Now, artificial intelligence back in the days, we did not have models which are already available, right? So available as an API, as a service, right? And nobody was hosting it. You had to build your own models. When you build your own models, the overhead, right? You cannot go to the infra team every now and then tell them, I need so much, this GPU, this compute power and everything, right? So you had to have something right there and then you tell them, and then that is provisioned immediately, such that experimentation, building your models, because these were mostly experimentation back in the days to understand whether it is going to work, it is not going to work, model drifting, multiple these sort of things had to be taken care of. So that is where cloud technology became one of the core components or the core factors that had to be factored in while you're building your applications. And since then, it has been like the foundation layer, you're there, right? Started with software engineering, data systems, AI. Every time, the one core component that stayed was cloud, the foundation.
Correct.
That is
Yeah,
how I got
so
into it.
yeah, good to know about you. So now coming to, you mentioned cloud computing already. So let's coming to our topic. Let's start with the very basic stuff. So what is cloud computing in basic, simple terms?
Sure. So to give you a technical understanding, right? Basic technical understanding. It is like there is someone else. It is not somebody else's computer. It is like someone else managing all the resources, the infrastructure resources which is required for you to run your application. So your focus is, okay, I'll build a beautiful application, but now when I want to distribute it, when I want somebody else to use it, the infrastructure overhead or managing that infrastructure, somebody else does it for you. You go ahead and make the configuration and build the configuration around it, but somebody else does it for you. The infrastructure management, infrastructure provisioning, multiple regions. You want to scale it to like today it is like 100 users are using it. Tomorrow million users are using it, right? So that scale, right? That scale is somebody else managing it for you. Now this is only possible because of cloud computing, and that is how it is.
Yeah. So basically, businesses can manage their businesses, and infrastructure and storage is managed by the cloud companies.
So give you an example again, startups, right? Startups in particularly, you build a product and then you are sleeping. 100 users are there. And tomorrow something happened on X or Twitter, somebody posted about your product and now it is like scaled to 10,000 users, 1 lakh users or a million users. You never know. So now this kind of scale, now this scale, you cannot manage it using on-prem servers. You cannot get your CPUs and GPUs on in your warehouse and then manage that kind of traffic, right? Now this is only possible with cloud infrastructure because that scale and elasticity, it is the provision that it gives you, right? The luxury you only get through cloud computing. That is how the resources are managed.
So you mentioned about startups using the cloud computing. What about the larger enterprises? What is the use case for that?
Indeed. See, startups, it is more like uptime, so upfront friction that gets avoided with startups. So startups don't need to, they can focus on their product, build it, deploy it on cloud, and the cloud infrastructure, it takes care of the infrastructure. When we talk about enterprises, now enterprises have been there for a long time and they've got legacy system, legacy application. For them, most important thing is they already know their customer base. Resilience, right? Resilience, reliability, all right? So these are paramount for them. Reputation is at stake always for large enterprises. Your application cannot go down. And we are talking about such huge enterprises or like someone like who has like presence over 50 countries, 20 countries or whatever, right? Multiple region, their application availability is paramount. It is very important. So person sitting in the US, you've developed your application, hosted it here in India, but your application also gets hosted in that one of those regions wherever your consumers are there, right? And now this reliability and then availability, always available. Now this is something that enterprise requires all the time. So which is why startups have different use cases to solve. That is uptime, friction gets resolved. With them, it is like reliability, resilience. That is very important for enterprises. That is how cloud caters to both these
Larger and the smaller.
Yeah, the audience, right?
Correct. Okay, so now we keep hearing about software as a service, platform as a service, infrastructure as a service. Can you kind of break it down into understandable terms?
Good question. It always feels like some buzzwords, right? IaaS, PaaS, PaaS, and SaaS. Let's start with IaaS. Now, IaaS, infrastructure as a service. The name itself tells you infrastructure as a service. Now, see, for example, there's Azure, AWS, GCP, huge cloud infrastructure. Cloud providers, cloud service providers. Now, these people, what do is they've got enough storage space, they've got enough compute space and performance and everything built in. We, as say an enterprise or a software developers, now you know or you want to manage everything. You want most control. Okay, so you'll get that infrastructure as a service. They'll just give you the servers. Take this server, build your application, put your OS, put everything that you want, and that is there. Okay, but now you've got all the control, but with control also responsibility stays with you. Okay, that is infrastructure as a service. Platform as a service, it is like we'll give you the compute, we'll give you the resources, will give you the operating systems, the management and everything as well. Okay. But it is your software at the end of the day. So which is like the container is there, okay, to run and everything. You develop your code, you put it inside that, and that gets shipped. Now people using it will be able to use it, will get scaled, all elasticity, everything is built in. Software as a service, on the other hand, classic example like Gmail, Microsoft 365, Excel. Now these are like softwares which are being built by the cloud providers or the service providers. They deploy it and then you start using it. Okay. Now to give again a real world example, if I were to take it, it is like you get the raw materials, and if I give you, and we want to build a building, right? I give you the raw materials, I give you the resources. Okay. Now these are like 10 people or 100 people, whatever is required, all the equipments and everything. You build it. The building, you build it and everything. PaaS, that is infrastructure as a service. PaaS, that is platform as a service. You get a flat. Okay, I give you a room and everything. Now furnishing, it is your responsibility. You furnish it the way you want it. You design it the way you want it. That is platform as a service. Whereas software as a service, it is like a service apartment, like a hotel room. You just walk in, use it, pay for it. Right? So the core trade-off between all these three things that we talk about, like IaaS, PaaS, and this thing, is about shared responsibility and control. Okay, so with more, whatever responsibility that you take, the control, right? IaaS, more control, but responsibility is also at the higher side. Similarly, PaaS, medium control. You don't have all the control. The resources are managed by them, but still your software is yours. So you get, the responsibility is still at the medium level. Software as a service, it is like no responsibility at all. No control. It is like everything is, they're creating it, you use it. But then also cost component differs between all these things.
So another term which comes out with cloud is public, private, and hybrid. What are these formats of clouds?
So public cloud, right? I'll give you examples also as to what are the particular use cases of public, private, and hybrid. That will really make more sense for us to understand. So public cloud, say you build an application. Again, you're like a startup. Say, for example, you're a startup. You built an application. You have your data and everything, customer data or whatever data that you're talking about. It could be something like an e-commerce website that you've built. You can go ahead and use a public server. Why? You deploy your database server, you deploy your application, you have your users, it is scaling and everything. Everything is taken care of. Performance engineering, management, everything is like all sorted there. Okay. Now that is my public server, multi-tenant availability, all of that is there. Now this is Azure service that you're using or AWS or whatever that you have opted for. Okay. It is there. When we talk about private cloud, the differentiating factor here is that, say you are a bank. Now you have some customer data, some financials. Okay, now that is very important for you. Important in the sense, it is something that you cannot just give it out in the public and anybody else who is also using that same server. Okay, not at the same time, but at the different time when your availability is low. You don't want that to happen. So which is when you set up your own private cloud. Okay, now this private cloud could be set up through any of these cloud providers also, but you can do it all by yourself. Like you can hire a data center like your time, and multiple different data centers out there, right? So you can go ahead and then provision your own private cloud center, and whatever development or everything, or these data, this data, like particular data that I was talking about, it can go ahead and you can just deploy it there and it will stay. Okay. Hybrid, on the other hand, is something this banking or large enterprises prefer. Okay. All the application, customer facing application, which doesn't have data, it is not much data intensive or something like doesn't have any data which needs to be secured at the highest level. Those applications go on public. PI information, financials, customer information goes on your private. That is how they manage it. And now this is like mix of public and private both. So you've got your hybrid cloud infrastructure setup and being used.
Okay. Is there any example which you can give for public cloud, for example?
Public cloud would be something like Azure, AWS. That is your public cloud. Okay. Again, on Azure, AWS, you can use that as a private cloud as well. Private cloud in the sense you create, see, again, startups, right? I took startup as an example. Startups can go ahead and then deploy their application. It is there on public cloud and private cloud. Sorry, public cloud. Any application that you build and you'd want to put it on cloud, it is public cloud in general, unless and until you provision for it and you want to create a private cloud infrastructure particularly. Okay, wherein you want to secure your data. So data security is that very important thing when people go ahead and then have private cloud provision for it. And a hybrid, again, same, mix of both.
Okay. Now, coming to the real topic of the podcast. So we are talking about cloud or cloud computing in the age of AI. So, is there any connection between AI and cloud computing? AI is going to have a positive, negative. What kind of impact it is likely to have?
Yeah, indeed. I mean, see, it is like made for each other sort of thing. Okay, AI and cloud. Before cloud, I mean, it was like the resources were not available for you to start working with it. I mean, the compute resources. And also, if you think about it, see, people have been discussing, or AI has been a jargon for a long time, and people have been discussing about AI. Yesterday itself, I read something. One of the Malaysian guys, I mean, he bought AI.com back in 80s or 90s, and he sold it
It was some
yesterday.
500, 600 crores.
$600 million or something. I don't know the crores or $1 million, but it was like pretty huge, the difference, right? So people knew AI and people knew machine learning, statistical algorithms using R, Python were being built. But the only delimiting factor there was compute resources. The compute resources was not at that level which it is right now. Okay, and it only took up, I mean, both this, I mean, everything has to be balanced, right? I mean, you need, in order to build your AI systems or AI models, you need to have corresponding compute resources, which is required, okay, at the same level, same scale. So it is intervened very heavily, tightly coupled. Again, so all these models like OpenAI models or Anthropic models, these models which they are building, it is all using GPU clusters and everything, which is being powered or which is being provisioned on the or available on the cloud platforms or cloud services, and that is where all this, every now and then, every day we wake up and we are like, it's like new model that comes up. It is because of this cloud infrastructure which is available at this moment. Right?
Correct. So the infrastructure it is getting built at a huge rate, right? So Elon Musk is trying to build it in space.
Yeah.
So, but is AI going to increase or decrease the cost of cloud computing as of now? What does it look like?
Yeah. See, it is definitely going to increase. I mean, the cost at present, what we see is the applications and everything that we built at our organization, right? I mean, it increases the cost. I'll give you an example, okay? So it was just about last week or something. We were working on one of these applications and we had to put down the OPEX, I mean, the operational expense for one of the applications that we're building. Now, the cost of building this not the building, but building and deploying this application on Azure or AWS. Azure, AWS, GCP, we did all three. And the cost of deploying this application was about $5,000 or using this application was about $5,000 per month. That is fine. The LLM cost was about $50,000 per month. Okay, just look at it. I mean, and we are using LLMs to power this application. There were about 40, 50 agents which are there. So in order to power this, it's about $50,000. Now you can understand the cost. But again, there is a trade-off here. We're talking about value being driven. Okay. Now this application that I'm talking about, this application reduces the overhead or the lead time of building a service. Okay, building a service. It is data engineering focused service that we're building there. So it reduces the overhead or the lead time of about 10 to 15 days of skilled workers or skilled people. Okay, highly skilled people. So it's like 15 days ka job gets reduced to like 1 hour, 2 hours, and it is done. Okay, or probably lesser than that. And most importantly, the information access. Okay, something that gets built and gets deployed and being used by the senior stakeholders, and now the senior stakeholders, CEO, CTO, C-suite people. Okay, so that value being driven, and then that value gets transmitted. I mean, gets delivered to the customer. Right. So everything that would have been done within 2 years now gets done within a month. Now it is not just the inference engine or the computation is what I'm talking about, the technical side of things, but the value as well. The value which was being driven or like delivered to the customer in 2 years gets delivered in a month now. Okay, so now that is the impact that it's created. So again, the cloud cost, if you're looking at it in isolation, yes, cloud cost goes up, but the value also significantly goes up. So that is why people adopt to it and then people start using it. And people would want to, everybody wants AI right now, right? That is how it is.
So for an enterprise or for an organization, how does AI impact their kind of cloud strategy? Saying, okay, we have to go on cloud. How does AI impact, or is it going to have any impact?
It does. I mean, it is highly impact. See, now until 4 or 5 years ago, I mean, before the advent of ChatGPT or generative AI, right, particularly, these discussions were like between the rooms, I mean tech rooms. I mean people from the DevOps side or people from the technical side who are building this application. These discussions were between them or at the most CTO level. Okay, but now it has become boardroom discussions. I mean, what happens is, because these applications which are being built are being used by the customers, direct customers. So AI governance, okay, cost volatility. Because at times what would happen is the cost would go significantly up based on whatever. I mean, since you are not able, the retries of generating a response. I mean, in order to avoid multiple risks, right? Retries, like 3 retries instead of 3 retries, you'd not put a threshold there. And it's like it keeps on retrying itself. The API cost goes significantly. So cost volatility, model risk, right? Whether to go with proprietary models or whether to go with open source models, right? That drives your cost volatility, and also the output that you data residency. Okay, your data at rest, data at transit, whether these models are consuming our data, and then is our data going into the public. Okay, because there is no set framework, there's no textbook, nobody knows as to what is going to happen. Although all these cloud platforms promise you all the NDAs, and with all the NDAs and everything that you've got, but still people have this fear. Okay, so now these are boardroom discussions that happens in order to take this decision, that what to go with. So which is why, again, when you're building applications, the application get built and cloud becomes a part of it. But these discussions, and I mean, still unanswered, or people take a leap of faith. Okay, let's do it.
Okay. So does AI bring in any kind of a risk into cloud computing or cloud strategy, which enterprises have to consider?
It is just the data. The data residency is the very important problem. Okay, data at rest and data at transit. Now, what happens is, people, like I said, right, public cloud, private cloud. So private cloud, when you have deployed yourself, Snowflake. Okay, you have deployed your own data, customer data. Okay, customer data, you are, say, a bank. You've deployed your customer data, and now you're building an AI application. Now this AI application is going on Azure. Okay, now you want to access this data. Okay, want to make some read write operations. Now that is going to happen. Now there is one thing. What happens is, there is something on private cloud, this is on public cloud. When you go and try to read this data, there is some latency that kicks in, right? I mean, because you are moving from one infrastructure to another infrastructure service, right? Now, in order to reduce this, you can always get this data here. Okay, but if you get this data here, there is still a risk, because this data is exposed to your within your application, is exposed to the LLMs or the models that you are using. Now, which is why they hesitate. They are like, okay, we are okay with the latency, but let's have our data right there on Snowflake or on my private cloud, and let's not bring this data out here in public. Okay, so now data at rest and data at transit, that is the focus point. And everybody focuses on that, and it is not just about redaction. You cannot just go ahead and then read. We promise that, okay, we'll put in some guardrails, we'll redact the PI information, and then get. No, it is not just that. It is little beyond that, because this data gets consumed. Everybody has this fear that the large language models and everything that's being built, right? They are using our data, they'll use our data and to train it. So data is out there in the public, and nobody wants that to happen.
Another problem with cloud providers is it's literally lock-in, right? Once you move into Amazon or Google, moving out is not an easy task. But looking at the AI, the rate at which AI is evolving, now, does that become a bottleneck for the enterprises?
See, what happens is, it does become a bottleneck if you're talking about vendor lock-in, right, particularly. But larger enterprises, how do they deal with this problem is that they know that there are models. When we talk about OpenAI, Anthropic, see, OpenAI on Azure, Cloud models on, Cloud models, Anthropic Cloud models on AWS, and Gemini models on GCP, right? Now, each one of these models, if you look at it, are good at something. Okay, like for example, if you're talking about Sonnet models or Anthropic Cloud models, they're good at reasoning. They really give you good reasoning ability. Whereas OpenAI gives you something else. Gemini gives you something else. Okay, everybody has their own pros and cons and really good at something. Enterprise tend to adopt multi-cloud adoption strategy, wherein what do they do is, or what is something that is preferred. Okay, not blindly, but it has to be like thought through really well, whether you really need it. So you have Azure, you have AWS, but probably you have Gemini as well, a GCP. Now what do? You build your own platform. Wherein what do? You get OpenAI models, you get Anthropic models, you get Gemini models. You also get some open source models. Okay, DeepSeek, Llama, any VLMs or anything that you want. And you build your own platform, you build your own AI gateway. Okay, now when you build your own AI gateway, you deploy it on your cloud. And now what happens is, anything that comes through, and you try to put in your own security guardrails also around this AI gateway. So any request or anything that comes in, it gets vetted, and you are very sure now, because you know what is going to happen, and you can access whichever model that you want. So vendor lock-in sort of gets avoided by adopting multi-cloud adoption, by adopting this multi-cloud strategy. And that is how you can like probably scale and always have whatever model that you want at your disposal by you having your own AI gateway.
Okay, so one last question in this segment. So, how do you think cloud is going to evolve as we go along, especially considering the way AI is getting into the picture?
Autonomy. Okay, now see, we talk about the cloud is again, it is not averse to things like failing. It may fail. Okay, it may fail in the sense what happens is you deploy an application, you put your application, but at times, see, there are things. I mean, within cloud particularly as well, you put one service, you deploy one service into one of the containers, or you can just think one of the boxes, another service in another box. Now, in order to these two boxes or these two services, if they want to talk to each other, you've put in a security and you've not configured it well. Okay, and what happens is you are not able to figure it out even through the logs. I mean, there is a lot of fine print into those logs, and for you to get into the depths of it and try and understand, it is time consuming. Now, but you'll eventually figure it out, but then you've already wasted 3-4 hours into that. Okay, now these analyzing these logs, identifying the root cause, okay, and then giving it back to you, are probably going ahead and fixing it. Now this autonomy, that I believe will get built into cloud. Okay, and that is how it is going to reshape the entire cloud infrastructure in general, wherein AI agents, particularly AI agents here, would understand your requirement, your resources, and everything, and then it will probably deploy whatever you want. But again, in order to failover mechanism, right? More like failover mechanism, wherein it analyzes your logs, understands things, fixes it with human in the loop, of course, because we don't want it to go ahead and provision whatever random things just for something like this. Okay, human in the loop would be required, but then again, the time to resolve these issues would significantly go lower. Again, any vulnerabilities that is there, okay, in the configuration that you have done. Okay, if that is not really right, in that case, that also gets highlighted, that also gets identified, gets notified, right, to the DevOps engineer, and they can always go and fix it.
Another problem which is there, so this is a related question, is cloud waste.
Okay.
Okay, so there are a lot of talk about people not even able to utilize 100% of the cloud cost which they are paying.
Correct.
Right? Can AI help them in kind of optimizing that waste?
Right. I mean, see, at times what happens is AI is also one of those parts because of which people are not able to optimize cost. So again, AI can definitely help them, but cloud cost, right? We need anybody who's working with cloud. They need to have really good cloud architects. Okay, system design thinking. You need to know that what you are exactly using. Now, this cloud waste can get avoided with this first level of defense. I mean, we are talking about this. Okay, you need to know exactly what you're using it for. Second thing is that AI can definitely come into picture in order to help you avoid that. But again, FinOps or cost observability, okay, people don't focus on that in general. When you're building an application, that has to be one of those, whether you call it an operation, I mean, it's more like an operational thing people believe. I mean, the developers particularly, they believe that there's an operational thing. I shouldn't be caring about that. I should be focusing on the logic that I'm building. Okay, but that also is a very, very important part. Only and only when, if you're able to measure something, you'll always go back and fix it. Now, cloud waste, I mean, particularly cloud waste, is this term. This term particularly exists only because we are not measuring things at all. If you know how to measure it, or if you are focused on measuring it as well while you're building it, large scale enterprises and everything like SaaS models and everything that gets built, analytics gets built in. Okay, observability gets built in, which is very important. If you're building the observability, you can always go ahead and fix it. Now, once you are able to fix it, you know how an AI agent would be fixing it. Cloud service providers, definitely they'll bring in something, or there are a few things like a lot of these observability platforms like ML 3 and things, right? ML 3 particularly. Now they give you very easy to work with, and very easily you can build it and integrate with your application, this AI application, and you have all the agents. You know inference cost for each one of those, latency and everything. Now this observability available at this high stage and this level, you can always go ahead and build an AI agent in order to optimize for cost and then understand what is the cost and everything.
Okay, so now let's talk about a little bit about careers and skills in cloud computing space. So it is a promising field, and the way enterprises have spent money on this It's not going to go away so soon. So, what kind of a careers are available in this space on a broad term?
I mean, a lot, right? I mean, I'll tell you. See, at least particularly in India, if I were to talk about, okay, if you talk about US, Europe, I mean, there are multiple. I mean, one job is being done by one person only, and then another person for different job. But even in India, if you talk about it, wherein people tend to do multiple or tend to shoulder multiple roles, in that cloud architect, okay, cloud architect, because system design is paramount. You talk about anything, you can always write code, you can always go ahead and look up for syntaxes, okay, but system design in paramount. You need to understand the system design, how to build things, okay, how to optimize for things, how to use the resources. So cloud architect. Then comes DevOps engineer. Now DevOps engineer is someone who takes or ships your code from development to production, okay. Now this one. Third thing is security engineer, cloud security. If I were to tell you, or if I were to talk about two things or two fields particularly, which are at the highest value currently, there is AI. Second is security, cyber security. Okay, so security, because when you build application at such high scale, the time to market has reduced significantly. Okay, unlike before, we used to take like 3-4 months. Now it is like 15 days. You have your POC ready, you have your application deployed. If it is like small scale application, you can easily go down with cloud code and everything. I mean, there is another story, but yeah. Again, when you build this application, people tend to ignore the other things, like I mentioned, cost observability, right? Again, one of the other very important thing is security. And security, large enterprises don't ignore it, but smaller ones do ignore this. So security engineer would know as to IAM configuration, okay, identity management, like authorization, authentication of the user. How would that happen? Data at rest, data at transit, data moving from one application to the another. How do I secure it? How do I have really good guardrails? I mean, preventing it, even if they are not first hand developing it, but they should be the one in order to ensure data once it leaves the database and going to another, being accessed by another service. How is that supposed to happen? Supposed to happen through API. Should not be a direct SQL query somebody goes and files. So security engineer, very important role. Okay, so I said cloud engineer, there's security engineer, there's DevOps engineer. Again, two particular fields which have gained traction in the recent. MLOps has been there again. MLOps, okay, machine learning operations. How do you build your own model, find your own model, deploy it, and use it. Okay, and AI platform engineer. AI platform engineer, because I mentioned, like, multi-cloud. When you're building multi-cloud and you're building your own platform, you build your own AI gateway for yourself. In that case, AI platform engineer, very important. You build guardrails as services, okay, every guardrail, and then whatever application that you use, you can go ahead and then stitch it. I mean, you can just integrate this through these guardrails, any other features that you have created, right? Any LLM models that you want to use as an API, you can straight away use it. So these 5 roles particularly.
So are these roles which are tech or the programming based roles, or and is there any provision or any opportunity for somebody who is not a kind of a techie guy or not a programming guy?
See, all these roles that I mentioned, these are particularly tech focused, okay, program focused. I mean, somebody should know programming, only then they'd be able to do justice with these roles. But if I were to talk about somebody from the non-tech background, right, BAs, business analyst, project managers, like product managers, these people, they understand their products well. Okay, at least product manager understand the product well, business analyst also understand the domain side of the things. Now, they shouldn't keep themselves away from technology. If they are a part of the software being built, where would their role come into picture is like FinOps, observability. Okay, like we spoke about these things, because for them it is like cost volatility. If cost is going high or cost is going up, traffic is not going up, but cost is going up. So there is some issue there. Okay, so FinOps and then cost observability. This is something that they can easily go ahead and focus upon. Okay, and again, other strategies, right? Any sort of automation or anything that they would want to build in, they can always go ahead and direct the developers to build in, which they always do. But cloud perspective, FinOps and cost observability can something be their primary focus.
Right. So, in fact, business analysts can also, analysts or product managers, they also have a role to play in the cloud computing space. Okay. Now it's time for a rapid fire round. Quick questions, true or false kind of answers. So, cloud is always cheaper compared to the on-premise.
It is not always cheaper. Misconfiguration. Configuration is very important. How do you configure your resources? That is very important.
Another kind of a fact check. Cloud is not secure. True or false?
Again, misconfiguration. See, it is secure. Cloud providers have been spending billions of dollars in order to ensure that security is there. Okay, if you're not configuring it properly, if your IAM is weak, if your authentication is weak, your authorization is weak, your data is lying out there in the public, in that case, of course, it is not secure.
Another misconception or truth. There is no downtime if you're on cloud.
No, there would be downtime. You need to build that resilience. You need to go ahead and build the resilience that you want to. Okay, so like for example, if I built an application deployed on region A might go down tomorrow, but then I need to have that multi-region tenancy being built in. Okay, such that one goes down, traffic gets directed to another.
I think there was a recent downtime on AWS platform.
Yeah,
One day or something.
Yeah, right. It was there. Correct. So it is never. Nothing. You can never say never.
Yeah. Okay, one most overhyped cloud trend.
Multi-cloud adoption I spoke about, right? Twice or thrice. But multi-cloud adoption, if you're not strategizing it properly, then it is overhyped. Completely overhyped, and you're doing it wrong.
Okay. The opposite question, most underhyped cloud trend.
Cost optimization, observability.
Yeah, FinOps.
People don't focus on that.
Okay, one skill that will be very crucial for tech guys in the future.
System design. It has always been, it will always be.
Okay. So, last question. Anything which you want to say about people who are either entering the cloud computing space or they're planning to enter? Anything you want to tell them?
Sure. So now see, I'll give you a little big answer on this one. You're done with your schooling and everything. You're pursuing engineering, you're pursuing whatever field of your choice. Always know that it is a professional course, right? So whatever you're doing, do it with all your heart and everything. Okay. So when you're entering into tech field, now moving on to AI, cloud or whatever, right? You need to know that what problem you're trying to solve. And you're here at point A. The problem is there at point B. When you're trying to solve that problem, you need to build the shortest path. When we talk about shortest path, you need to optimize for the resources that you're working with.
Correct.
Okay. So, and everything in between is system design. Everything in between is system design. Think from an architectural perspective, because if you're an engineer building something, you need to know as to how do I build it with the in a best, efficient and the optimized way. So always focus on system design. Programming languages, tools. It comes and goes. And it is like ever evolving. You cannot learn 100 programming languages. You cannot learn 100 tools and thousands of tools which are out there, right? System design, it is just one thing. Learn that and you will be good at everything.
Good answer. Really well said. So, last question. I said last question, but this is the actual last question. So, if people want to reach you after this podcast telecast, where can they reach you?
Well, of course, always open to talk to students, professionals, or anybody. You can always reach out to me on LinkedIn. Okay, I'm always available there, and DM me there. Anything that I could help you out, provide you any guidance, of course, always available.
Thank you so much. Thanks for your time.
Sure.
So this was the episode on cloud computing in the age of AI. Hope you enjoyed the episode. We'll see you in the next one. Thank you.